Hello everyone, in this video we cover the languages this a raised to n, b raised to n, a raised to n, b raised to m, and for that two language we draw the PDA. So let's start. So first we draw the PDA for this language. First a raised to n, b raised to n, where n is greater than equal to 1. So I hope now you built your logic, and if not then we see here. So first if we consider this n is equal to 2, so a raised to 2 means a, then b raised to 2, n is equal to 2 we consider, so b. So this is the language string, and here this is the stack. So initially z0 is present in the stack, and now we read a, so we push the a, again we read a, push the a. Now we read the b, so for this first b we pop the first a, then second b we pop the second a. So in this way, if a is equal to 3, n is equal to 3, then for the 3 a's, for the 3 b's we pop 3 a's. So in this way a raised to n and b raised to n means for the b raised to n we pop the a raised to n, equal number of a's and b's. So this is the logic for this language. So let's we draw the PDA for that. So first at the initially what we perform here, we push all the a's. So initially z0 is present in the stack and we read a, so what we do, a z0. Now second time, now a is present, so initially a is present, then we read a, then push the a's, so a. Now here we write b, no, because always the string is start from a only, not b, so only a we push. Now we want to pop, so one push operation we perform this q0 state, and now for the pop we take the another state. So this is the q1 state, and here we perform the pops. But how? First initially a is present, then we read b, that time pop the a. Now again the cycle is formed here. If n number of a is present and n number of b we read, equal number of b's and a's, that time pop the all the a's, and then at the end we read null, and initially z0 is present, that time kept this z0 as it is, and we now in the final state q2. So this is the final state, and this is the PDA for this language, a raised to n, b raised to n. And now I hope all you get idea about the language and the PDA. Now we see the next language, a raised to n, b raised to m, where n is always smaller than equal to m. So let's suppose n is equal to 2 and b is equal to 4. It may be anything you assume, not b, m. So m is equal to 4. So for that, so what logic can we apply here? So let's we first write this string. So string is a raised to 2 because n is equal to 2. So a and b raised to 4. It can be 5, 10, anything. So b raised to 4 means 4b. 1, 2, 3 and 4. This is the string. Now for this 2a we pop this 2a. B means for when we read these two b's, that time we pop these two a's. Now remaining b's, what we do, for that b when we read, then we kept this b as z0, or we kept transfer this b to the null. So this is the logic here. So for this a raised to n, b raised to n pop, so let's here a raised to n, and here b raised to m means nothing but m minus m raised to n plus something x, let's we suppose. So combination of this m is formed because n is always smaller than equal to m. So here let m is equal to 10 and n is equal to 2. So here first 2n is the present and then remaining 8 are the other. So same logic we apply. First b raised to n, for that a raised to n we pop, and remaining which x is present, that x we translate into the null. So in this way we perform here. So we see here in the stack also, initially z0 is present, then we read a, push a, again if you read a, push a. Now if you read b, then first pop this a, again you read b, pop the a. Now here only z0 is present and remaining b are also present now. So when you read this b, that time this z0 kept as it is, means if you read b now, kept this b to the z0, means again here z0 only present. Then again you read second b, so kept this z0 as it is. So in at the end only z0 is present in this stack, and we can say that we are in the final state. So we draw here PDA also. So Q0 initially, so initially z0 only present, and if you read a, that time push the a z0 combination. Now again a is came, so a is present initially, again we read a, push the operation. Now we want to pop, so for that we take the next state Q1. But what we perform on this state, initially a is present, we read b and pop the a's. Same cycle here we form. So for the first initially a is present, b is read, so for the a raised to n we pop the b raised to n, pop here. So all the a's now complete here in this state. Now one more transaction we write here. Now all the a's are the completed, so we read z0. So initially z0 is present, but again we read b. So what we do here in this state, kept this z0 as it is, not push the a or push the b, otherwise not pop the b. Kept this z0 as it is when you read the b. So this is done in this state, and at the final state null we read, z0 is present initially and kept this z0 as it is, and we are in now final state. So this is the PDA for this language a raised to n, b raised to m. Now I hope all you get idea about this PDA. Simply for the a raised to n, for that b raised to n we pop, we take the combination a raised to n and b raised to n, and remaining b raised to x combination, for that we kept z0 as it is, and all the string when completed, then we are in the final state. Now one more thing, if the question are the for the less marks, means 3 to 5, in the range of 3 to 5, then only PDA if you draw, then it is okay. But let's suppose the question are for 7 marks or 8 marks, that time only draw the PDA, is it not okay? So we write here one table also, transaction table, how we perform and what we perform. So for that, first column is move number. This is nothing but the serial number. Then state, and then you write input symbols, then stack symbol. This stack symbol is nothing but the initial symbol. So symbol, and here we write move. So this is the initial state we can say, or symbol. So these are the columns for the table, and here I show you simple way to write this. So here we write serial number, so write 1 2 3 and 4, then continue remaining. Here state, so from which state we start? Initially Q naught state we start. So here first state is initial Q naught, where we start. So this Q naught, and for this transaction how many initially we read? So kept write this all the things as it is here. Means input is Z naught, sorry, input is A, then initial state Z naught, and our move is A Z naught. Means kept write all the bracket as it is here, one by one. First here write A, then Z naught, right here Z naught and A Z naught. So here A Z naught. Again here one more transaction is present. So write as it is this whole bracket. So first state is Q naught. So Q naught. Then input, write all the things as it is here, one by one. So A. Now the transaction is changed. Q1. So right here Q1. And for this Q1 again two transactions are the present. So write Q1 two times here. Then first bracket write as it is here. So first B, then A, and then null. So B, A, null. Then A Z naught Z naught. B Z naught Z naught. So B Z naught Z naught. Then for the Q3 state, which is the transaction, this null Z naught Z naught. So right here Q2. Otherwise the final state is not right, then also it is okay. Only the transaction we write now. So here is not any transaction we doing on this state. Initiate this two state, all the transaction are perform, and finally we are in the Q2 state. So this state is not right here. So initially all the moves only we write. So I hope all you get idea about the table how we write. Only just this transaction write as it is here and give the name. So Q1, so for Q0, for the Q0 two transaction are the present. So we write 2 times Q0. Then first transaction write as it is, second transaction write as it is, then Q1 state is come. Write Q1. Again here 2 transaction are the present. So we write 2 times Q1. And this transaction BA null, BA null, B Z naught Z naught, B Z naught Z naught, and completed. Now our whole the question is the ready. So in this way please write the answers. So I hope all you get idea about the questions, and if now any doubt or any query, then let me know in the comment box. Thank you.